Good afternoon, ladies and gentlemen. I've been asked to just give a very short and timely discussion on one Swiss S&C extension method. It's actually been in the UK for 10 years. It is approved for the UK infrastructure, and it's actually been installed on about 35 S&C units across the UK. And one of the success stories of this was the first site that was done was at Oxhays in 1995. The desire was to try and extend the life by 5 years, and I think it's just about to be renewed. So it's a good testament to the system, and it can give dividends to the infrastructure. So with every design of an infrastructure, a machine, anything you do, it's every part of that design and component working as it should do to create a stable platform, more so in the railway than anywhere. So every part from the formation to the rail to the overheads create an infrastructure that relies on every other component doing its job. In certain circumstances that can actually create scary examples. So you can buy this from most garden centres. And this is only a small one in China. They actually go to about 30 stories with bamboo scaffolding tied together with string. So it shows that every component, when it does its job, then the outcome is a full system. When one part fails, a single stitch can create catastrophe. Absolutely. Okay. But on a more serious note, the consequences to our industry are frightening. And we've all experienced those in one way or the other. So that sort of brings us back down to earth on the importance of each of those components and how we deal with the deterioration of those and how they work together. Now, unfortunately in the UK infrastructure, we've got a 14,500 approximately S&C units on timbers. And a good proportion of those have got issues with certain elements of the components within that whole system. And we're constantly, as an industry, trying to monitor those, to repair those in a costly, safe manner to create that safe infrastructure for me. Once the screw hole deteriorates and the screw allows movement, the amount of failures that can be directly contributed to that one part of the failure goes across the board, from drainage to gauge problems, alignment problems, derailments. It's endless. So once that starts to happen, and the moisture can get into the hole, everything starts to deteriorate quicker. And a list there of things that can start to accelerate from that single elongation of the hole, because timber is a live product, it bruises and it will under stress give. Once that starts, we're in a situation where things start to deteriorate. And it's proportionately that the more it gives, the quicker it deteriorates. Rail breaks, everything comes back to that one single component, including, in some cases, the ballast condition can deteriorate quite substantially as well. So just a bit of data for you, that track-related derailments, 30% on gauge spread. And switching crossings, 30% of derailments happen in switching crossings. How many of those happen because of gauge spread as well? The damage that causes to the infrastructure and the safe, the public and our workers. So of that 30% of S&C, you can see across the sort of orange line there, you can start to calculate how many affected our infrastructure. Thankfully, the majority of these are in sidings. So Network Rail have really assessed and understand the problem, and they're bringing CP5 an accelerated and determined effort to refurbish S&C on timbers. And this just gives you an idea of the volumes that, as an industry, we've got to try and tackle. With the concerted effort in CP5, that reduces the requirement in CP6. and also the concerted effort to get new units into the ground, concrete, reduces the amount of timbers going forward. So it's a problem that over time we can start to get a grip of this situation and reduce the risk to the industry. The Swiss Federal Railways had the same problem some time ago. So they had the scope that they came out was a simple solution. It's being administered preferably in adjacent line hosting. Probably something we wouldn't do. All they want to do is cover the gauge and bring it back to construction standards. They wanted mass usage, so no big machines, no complicated processes, so that single gangs of guys can go out with dedicated equipment in the process and start to tackle the issue. It has to be economic, because they've already paid for that infrastructure to be in, they've got to pay for it to come back out and be replaced. They want to extend the life, get a whole life cost up, so it's got to be economic. They wanted to try, if they can, to reverse the deterioration cycle, so not just hold it off, but reverse it and bring it back to the standards, so we've got a safer railway. And of course that all comes down to extending the life of the asset, to see if there's a financial gain there as well. And a logistical gain, because the amount of timber bearers that needed replacing at under S&C, it wasn't feasible. We had to do something about it. With the relationship with SBB and the CIRSA group, CIRSA developed a very simple system called SLS, Second Life System, to try and tackle this problem for them. It simply tries to get the screw to timber interface back to where it should be, and at the same time recover the gauge, super elevation and alignment. Now, once they started to look at this and started to do the jobs that needed done as an emergency, they soon realised that if they actually bring the interventions, they call it, forward, so it becomes, instead of a reactive solution, it becomes preventative, they actually decrease their maintenance costs. So as a standard now in Switzerland, so 90% of the infrastructure is treated at 10 years. And on the graph on the left is an approximation of what can happen in the UK and the problems that you will start to experience through the time of the SSC unit. And then they notice in Switzerland, if they put the intervention at 10 years, they actually pushed all of those problems backwards. They extended the life of the units by 30%. So they started a two-front attack. One was to treat the units that had been in 10 years, and one was to treat the units that had been longer to extend them the best they could. We've got in a situation now where the majority of the SSC units fit on the right-hand graph. They're in control of their maintenance programme. There is something like 1 million chair screws done in Switzerland, Germany and Russia per annum with this system. Russia is a recent market entry, so they're also going through the processes we were going through. Germany is slightly more advanced, they're probably in between the Swiss and ourselves. We've also started to see the same benefits. So once you get the screw hole stabilised with the screw, because that's the catalyst for everything else. Okay, I'm not saying that there isn't a deterioration of the railway that won't happen, but the majority of problems can be traced back to that one fault, or that one part of deterioration. So it's a prerequisite to bringing your unit back to standard and doing other treatments such as rebalancing. Because if you don't do that, all you're going to do is spend money, and then the same problem is going to happen again fairly quickly. So excuse my graphics, I'm not a graphics designer, and it was done on the train yesterday on the way up. So that's an exaggerated diagram of a typical turnout. And the beauty of the system is, even for some long bearers, you can change the alignment of the whole S&C without moving the long bearers. Quite often we've seen faults in the turnout that's not on the through road because of issues of someone's put the wrong piece of iron, then it's been tampered, and we're chasing faults. You can actually rectify that in long bearers. So first of all, we do a fairly detailed survey to establish exactly what is the problem and what we want to achieve on that unit. It's just re-gauging and free alignment. There's various things you can do. There's chair goal, all of those things can be dealt with. So it's establishing what do we need to do. That then gives us an idea of the time and the prep works that we may have to do. There is an element of timber changing, because the UK infrastructure we've found so far that because it's reactive, normally about up to 10 long bearers will need changing. Because the one thing that the system can't do, it can't prevent a timber sleeper from deteriorating. So if it's in a certain condition and the timber's not going to last 6 years, the system will last 6 years. If the timbers are going to last 15 years, the system will last 15 years. So it's important that you have a general condition of satisfaction. You pick a datum rail. You normally try and make that the nose rail because that's a heavy piece of kit to try and move across. And you can either 3D design it, or you can, if you're satisfied with the alignment, you can just tweak it. It's up to the engineer will decide with the client exactly what needs to be done, what the slews are. Sometimes we create a temporary forefoot with slews on the datum rail, and then use those forefoot dimensions to get the datum rail correct before we start gauging off. We fix tie bars, which I'll show you later on, which can manipulate the rail into the position we want it to go into. Once we've straightened the datum rail and refixed it, we can then re-gauge to the adjacent rail. This is where Neil's back-to-back gauge comes into, because obviously we don't want to go to the gauge, it's going to change as we rail process later on. Once we've done those two rails, we've already unscrewed turnout because we need that to be through the nose point. We can then pick one of those rails, straighten that, and then gauge off that. Single C-switch can be done by a single go in approximately 12 hours. Okay. If you've got back-to-back working, you can get a fair amount of work done on crossovers and such. You can stage the implementation. You've got to be very careful how you run gauge from the desired gauge to the existing gauge, how you run that in and out in between shifts, and how you change the alignment. So that is something you need to calculate as part of your on-site assessment. And you can do it over a series of nights. You've got to be very careful that it's structured. So the process is quite simple. We fit the fill bars throughout the site. They come in various sizes to fit in any part of any S&C unit, and the amount of movement we require will determine the frequency of those bars. They are actually insulated because in Switzerland they do it under traffic. So we'll have a reduced speed of 5 miles an hour, the guys move the position safety, and the train can come through because the gauge bars do hold them. I don't think that's somewhere we'll probably go in the UK. We remove the screws on the datum rail. We line the datum rail using the pull push bars. We re-drill the holes, and the system allows for an over-elongation of the hole because we put a steel insert in, which gives initial strength, like a wall plug-in effect. We use a resin, which will take up any of the slack in the adjacent hole. We fit the steel insert. We apply the resin underside of the base plate and into the screw hole. The resin we use at the moment happens to be an Evlon, spike fast. Any of those resins do the same job. What you're looking for is fast setting, something that's not brittle, it's not a glue, it's a filler, something that's approved. You fit the new screws and ferrules, and then you tighten the new screws. It's a fairly simple, but absolutely quality control process. If you get it in the wrong place and this stuff goes off, you will have a nightmare trying to sort it out. So the quality of installation is a key element of this. A well-trained workforce is absolutely essential. If you watch the Swiss do it, it's a group of 8 men all moving in a line, all with an individual job. It starts by taking the screw out and it finishes by the screw going in. And then you're at a very slow walking pace, and they're very practiced at doing it. So here you can see the pull and push bars. The ones that are more yellow here, they are insulated and they will move anywhere around about 150 millimetres, and they reduce in size going into the S&C. The pull bars. We also have a system where we use chains with ratchets for speed. And we can also, on some occasions, we pull off another structure somewhere if we need to move the alignment too far. Give an example on that 7-ton junction was on a new layout. And for some reason, with the speed on there, they couldn't get it off because it's calculated that the unit was actually slightly in one place. So we did a 3D survey, a double junction, and then bolted the whole thing apart from one rail over Christmas period, and we realigned the double junction in one rail data in 54 hours, and the speed came off 4 or 5 days later. So it's quite a versatile system. Once we've moved the datum rail to where we need to go, we re-drill using Garrud nut runner. We tend to find the speed that we need to go. We don't need something you hold by hand. We need something on a trolley now to drill. The drills are not auger bits, they're standard steel bits because quite often you'll hit a stone or you'll hit a water coil or something that you've got to go through. Tie bars are used for the alignment. The drilling rigs again are the rail mounted ones. Torque wrenches that we use are rail mounted and they're fairly hefty because we don't go to a torque setting. The operator determines when the ferrule is at the right distance down, because we can't guarantee the strength of the timber, therefore we can't go to a torque. So the operators have to be exactly on the ball. And fitting the steel insert, what we have to do, the steel insert, as you can see there's quite a weird shaped piece of stainless. That has to be knocked in so it's actually in the timber, not still touching the base plate, otherwise you just won't get the screw. So again, it's about the well-trained timber. Okay, we lift the rail approximately 20 millimetres at the point of putting the resin. We feed a spread of resin underneath the base plate to take up any imperfections and to take away any areas where there may be water egress or those sort of things. Get a good solid base. We fill the holes, not quite to the top, otherwise we get the wastage that you see in the left-hand picture there. We're looking for just a little bit of material to come out because you know then that the resin has actually impregnated the timber under pressure. The screw, as it goes in, forces the resin into the timber. Now what we do is we heat the resin to 36 degrees. That allows it to flow, but it also allows it to go off quicker. Because we need this to be fit to run traffic within 3 hours. This particular material at 36 degrees, within an hour and a half, is the 50% strength, and 60% strength is fit enough to run traffic. So weather conditions are a big factor. In particularly cold days or if we've got a short possession, we also heat the screws to 50 degrees, which accelerates that curing process and knocks it down to about 35 minutes. So again, structured work through the possession to make sure that we give it enough time at the end before we run traffic. You're just reversing all of the problems that you've identified in the first place. So screw hole integrity, the interface, gauge, cant, cross level. We can use loop pads, which are DPE type material. So if you've got chair gore, we can put in a certain level of thickness pads to take away that chair gore. If you've got a bow timber, you can adjust it to your super elevation correct. Again, all that stuff needs to be identified in the survey process. And as I say, you can actually do a full geometrical redesign on a complex timber layout. The other thing you can do is plain line, because quite often we get asked to, there's a problem where there's not enough fixing. As they're trying to tamper a piece of track, they're losing a lot of sleepers because they're not solving the problem. Recently in a job in the Netherlands, I had 4 teams of people on a staggered work site, 1 team on each rail, separated by 50 metres, and we did with 3 8-hour shifts. We completed 4,500 sleepers. We can also do a conversion from a spike track to a screw track and HSC type. There are variations that can be used for. Thank you very much.